In section 7.1, we're going to talk about interest. We're continuing our study on money. Interest is the money that one person, a borrower, pays to another, a lender, to use the lender's money. The amount you deposit in a bank is called the principal. That's the initial amount. The bank specifies an interest rate for that account as a percentage of your deposit. So if you're putting money in the bank, like in a savings account or something, then you'll get a certain amount of interest each month. The bank is actually paying you the interest to let it borrow your money in that case. For computing simple interest, the formula is I equals P times R times T, where P is the principal, or the initial amount you invest or take out. I is the interest earned. R is the annual interest rate, and T is the time in years. Example 1 says if you deposit $500 in a bank paying 6% annual interest, how much interest will the deposit earn in 4 years if the bank computes the interest using simple interest? So we're just going to plug into I equals PRT. The initial amount, $500. The rate is 6%. We have to change that to a decimal, so 0.06. And T is 4 years. You'll gain $120 from depositing that. To find a future value of an account that pays simple interest, use this formula. So let's say here we found the interest, $120. But if we wanted to find how much they now have in the account, we'd have to add it back to 500 and get 620. With this formula, we don't have to add back, okay? P, R, and T are the same. We have the amount, the future value, will be the principal times 1 plus the rate times time. Assume that you deposit $1,000 in an account paying 3% annual interest for 6 years. Use the simple interest formula to calculate the future value of this account. So A is P times 1 plus RT. Your P is $1,000. The rate is 3%, so 0.03. And we'll multiply that by T, or 6 years. .03 times 6 is 0.18. So we're going to multiply 1,000 by 1.18. We get $1,180. And that's not just the interest, that's how much with the interest is in the account after 6 years. Compound interest. Interest that's paid on principal plus previously earned interest is called compound interest. So if your bank is just paying a simple annual interest rate, okay, then you'll use the simple interest formula. But if it's compounding, what that means is, like, let's say you earned $4 of interest in January, and now you have $104. So in February, they're going to give you interest on your initial amount, 100, plus that $4. And let's say it's $104.50, or no, $4.50, and so they would add that each time. If the interest is added yearly, we say that the interest is compounded annually. If the interest is added every 3 months, we say it's compounded quarterly. Assume that you want to replace your sailboat with a larger one in 3 years. To save for a down payment for this purchase, you purchase $2,000 in a bank account that pays 10% annual interest, compounded annually. How much will be in the account at the end of 3 years? So in the first year, your initial amount will be $2,000. That's what you put in. So at the end of the year, we plug in to our formula 2,000 times 1 plus the rate, that was 10%, times just 1 year. So we don't need to multiply by 1 there. And so we multiply 2,000 times 1.1 and get $2,200. So in year 2, your principal amount is $2,200. So now we use 2,200 for your P. And at the end of year 2, you'll have $2,420. For year 3, we use $2,420 for your P. And after 3 years, you'll have $2,662. Now, luckily, there's an easier way to do this, because if you're compounding monthly or even daily, that would take a lot of work in a table. But we have this nice formula, so you can do it all at once. Here it is. The amount accumulated is the principal times 1 plus the rate divided by M, all to the nth power. M is the number of compound periods per year. And N is the total number of compound periods. Okay, so let's try this out. You have seen a home fitness center on sale for $3,500. And what really makes this deal attractive is that there's no money down and no payments due for 6 months. Realize that although you do not have to make any payments, the dealer is not loaning you the money for 6 months for nothing. You have borrowed $3,500, and in 6 months, your payments will be based upon that fact. Assuming that your dealer is charging an annual interest rate of 12%, compounded monthly, what interest will accumulate on your purchase for those 6 months that you're not paying? So here's our formula. The principal amount is $3,500. Your rate is 12%, so 0.12. And here's where the new stuff comes in. So M is the number of times that it's compounding per year. So if it's compounding monthly, that's 12 times per year. And N is the total number of times compounded. Well, if it's compounding monthly for 6 months, then it's compounding 6 times. .12 divided by 12 is 0.01. Add that to 1, we get 1.01. Now, there's a little catch here. Don't forget your order of operations. You cannot multiply 3,500 times 1.01 here. According to order of operations, exponents comes first. So, and if you need to review your order of operations, let me know. I'll send you something. So we have to do 1.01 to the 6th power first and then multiply by $3,500. So in your calculator, you'll do something like this. And then you would multiply. Of course, if you put it in your calculator just like that, it'll take it. Because it does order of operations as long as you have your parentheses correct. So we'll end up with $3,715.33. So that's what you're going to be paying on now. If you want to find out how much interest that is, then you'll need to subtract off the $3,500. So you're paying $213.33 in interest during that 6 months that you're not paying anything at all. Example 5 says, upon the birth of a child, a parent wants to make a deposit into a tax-free account to use later for the child's college education. Assume that the account has an annual interest rate of 4.8%. and the compounding is done quarterly. How much must the parent deposit now so that the child will have $60,000 at age 18? So, again, we're going to use our formula. Only this time, we already have A. It's $60,000. And we don't know P. We don't know the principal amount. That's what we're trying to find. How much should they put in? If the rate is 4.8%, then that's 0.048. It's compounded quarterly. That's 4 times a year. So 4 is M. And N is, we'll go out to the side, compounded 4 times a year for 18 years. So N is 72. So we need to take one step at a time here. 0.048 divided by 4 is 0.012. Add that to 1. And give me a second to take this to the next page. Okay. Now, we cannot, again, because of order of operations, divide 60,000 by 1.012. What we do is, to get the P by itself, we're actually going to divide by all of 1.012 to the 72nd power. And that'll make it go away. So in your calculator, you're going to put 60,000 divided by 1.012 to the 72nd power. And you can write that. You can just put that in your calculator. Either you're going to have to raise the exponent first and then divide 60,000 by that number. Or you can put it in like this, just depending on what kind of calculator you've got. But assuming you don't have a calculator that'll let you use parentheses and all, then let's do 1.012 to the 72nd power. And you get this number. And yes, you want to write that all down and put it in when you divide, using as many decimal places as the calculator will give you will help prevent rounding error. So you'll end up with $25,418.76. So that's the amount that these parents need to put into the bank right now if they're going to gain 4.8% interest for 18 years and get $60,000. So that's pretty good. It more than doubles. What if you need to solve for n? You have to use something called logs. Now, we're not going to go over logarithms in this class. I'm not going to explain to you what they are or how to use them or how to do specific operations with them. I'm only going to show you how to use them for this one thing that we need. And luckily, they're in the calculator. So you'll just be able to put this straight in your calculator and do it. So Dee Dee has invested $8,500 in old Star Wars memorabilia. There we go. Which is currently increasing in value at 6.5% per year. If this increase continues at the same rate, in how many years will Dee Dee's investment double? So we're trying to find n because that's how many compounding periods, which involves the years, that there will be. So we're wanting this to double, first off. So $8,500 doubled is $17,000. So let's write down our formula here. And so our initial amount is $8,500, and we're trying to double to $7,000. That's A. The rate, 6.5, so 0.065. And let's see, it's per year, so it's just once per year. So M is 1. And we need to solve this for N. Let's do what's in the parentheses first. That'll just be 1.065. Oh, got an extra equals there. 1.065 to the nth power. And now we can go ahead and divide those sides by 8,500 because that's being multiplied by the 1.065 to the nth power. So that is 2 equals 1.065 to the nth power. Now, in order to get that n down, we have to take a logarithm. So here's what we do. We take the log of both sides. So we're doing the log of 2 and the log of 1.065 to the n. Now, how that helps us is that there's this little rule that says that if you have, let's say, log base b of x to the y, then you can put the y out front, and it'll say y times log base b of x. So that's the rule that we're using here. And it is actually equivalent if you take your exponent and put it out front. And so the nice thing here is that we've got still log of 2 on the second side, on the left side, but on the right side we can take the n and put it in front of the log of 1.065. Now, how did that help us? It allowed us to have n being multiplied, so we can very easily divide both sides by log of 1.065, which is just a number. So that we can find n using our calculator by just doing the log of 2 divided by the log of 1.065. So you just put that in your calculator using logs, and you get approximately 11 years. And then the last thing here is something called the rule of 72. To estimate the doubling time of a quantity, divide 72 by the growth rate. For example, if the annual growth rate is 6.5%, the doubling time is roughly 72 divided by 6.5, which is what we just found, about 11 years. So that's nice. And that's the end of the section.